This is so exciting. We get to graph trig functions. Welcome back. First lesson of the third marking period. All right, by now you've got your unit circle memorized. We know that this is 0. This is pi over 2. This is pi. This is 3 pi over 2. And you know all those places in between. We know that the ordered pair right here for the sine, cosine and sine is 0, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. All right. Let's put in pi over 6 just because we can. Pi over 6. And it's root 3 over 2 and a half. All right. And let's do 5 pi over 6 because that's fun. 5 pi over 6. It's at negative root 3 over 2 and a half. All right. Okay, so our goal is to plot these ordered pairs. No, not the ordered pairs. Just the sine value at the angles. So I've got a number line. This is 0. And then I'm going to have pi. And I'm going to have 2 pi. You notice the angles are in the bottom. So then let's put pi over 2. And this is 3 pi over 2. I'm working my way around. The axis over here is going to be the y value. It's 0. It's 1/2. Then it's what? Root 3 over 2. No, it's root 2 over 2. And then root 3 over 2. It's just the sine value, just the y value, okay? But I'm going to plot just the ones on the axis first. So at 0, my y value is 0. At pi over 2, my y value is 1. Okay, so this is 1. At pi, my y value is 0. And at 3 pi over 2, my y value is negative 1. And at 2 pi, I came back around at 0. Okay? Well, pi over 6 is right about here, and it's at a half. All right? Then root 2 over 2 is 0.707, so that's about here. Okay? So this graph is coming up, and it's going to come back down because here's 5 pi over 6, and it's at a half also, so it's coming down this way. And then we're at negative a half, and it comes around and goes that way. Okay, nice, smooth. It doesn't end. It's got arrows on it. It keeps going. All right. So my domain of this function, because it's got arrows, because what happens is I can go around this circle. So I'm going to switch to blue and go around the circle again. So now that was 2 pi. Well, now this is 2 pi and a half more. 2 pi and a half more is up here. And then I'm at 3 pi, so that's over here. I came back down, and then I'm down here at 1, and at 4 pi, I'm over there. Okay, so it keeps going and going and going. So my domain is all reals. Okay, negative infinity to positive infinity. And what about my range? Well, the smallest it ever is negative 1, and the biggest it ever is 1. So this goes from negative 1 to 1. Now you use brackets because it's included. Okay? Period talks about how often does it repeat. I started at 0, I came to 0, then I went negative and came back. It took 2 pi. I started at 0, I went up to positive 1, back to 0, down to negative 1, back to 0. From 2 pi to 4 pi is 2 pi. So my period is 2 pi. That's how often it repeats. Repeats. Okay? Now, I'm going to use these notes and we're going to do the reciprocal function because the cosecant is 1 over the sine, right? So the zeros become asymptotes because you have 1 over 0. It's undefined, okay? So this is going to be an asymptote. Here's pi. It's an asymptote. Here's 2 pi. It's an asymptote. Well, what happens when you graph 1 over 1? So at pi over 2, 1 over 1 is still 1. And 1 over negative 1 is still negative 1. Okay. Now remember, this was a half. So what's 1 over a half is equal to 1 times 2 over 1, which is equal to 2. So here is up here, and over here is here. I've got myself a nice little curve that goes like that. And over here I've got a curve that goes like that, because this was at negative 1/2. Okay? Funky graph. You got parabola up and one down. That's what it looks like. Here is going to repeat. Don't forget your arrows. I'm going to take points off if you don't have arrows on them. Okay? So this is 3 pi. And then this is 4 pi. Oop. And there's another curve down here. All right? Cool. So the range on this one, let's do range first. Let's first get rid of my algebra over here. Let's talk about the period first. I changed my mind. Period. How often does it repeat? Well, you got 1 at the top, 1 at the bottom. 1 at the top, 1 at the bottom. So it's every 2 pi. The range goes from negative infinity, because those are arrows, to negative 1. Negative infinity to negative 1, and it's included. And it also starts again at 1 and goes to infinity. The domain, it's everything except the asymptote. So the way we say that is you use set builder notation. It's all values of x such that x cannot equal pi plus pi k. All right? Actually, in this case, you don't need to put the pi plus pi k. So let's do this correctly. I don't want to teach you bad math. Okay? I'm going to put a k there. K is an integer. So it says 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. You're going to have an asymptote. That's why it's not included. Okay? And that's set builder notation. So on your quiz, we ask you, state the domain and range. State the domain and range. Okay? Now, before we roll on, I want to back up and talk about this function right here. If I move this line to here, okay, that this is 0, and this is negative pi over 2, and negative pi, and negative 3 pi over 2, and negative 2 pi. How in the heck do you get negative angles? Okay? So let's get rid of this stuff. Let's switch to pink. A negative angle means I'm going around the circle backwards. Okay? So I go back this way. I go 1/2 of a pi, so that's negative pi over 2. It's at negative 1. Okay? At 0, it's still 0. If I keep going backwards, I started here, and I go backwards to pi, I'm back to 0. Okay? I'm up to here, I'm at positive 1. I'm here, I'm back at 0. So my graph can have negative domain. It can have positive domain. All right? The same is true for the cosecant, because we said the domain was all reals. So you have to know how to graph the negative ones. All right? Good? All right. What about the cosine? Well, I'm going to draw my unit circle again. Because this time, we're worried about the x value. That's a 1. Let me clean that up. That's a 1. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Okay? When this is 0, the x value is 1. Okay, I have pi over 2. My x value is 0. At pi, my x value is negative 1. At 3 pi over 2, it's back to 0. Because remember, we're doing the x value. And at 2 pi, I'm at the top of the chart. So this is coming down. It looks very similar to the sine function, only it's got, we call it a phase shift. Okay, it shifted over. Okay, our graph started here at 0 and went up. That's over here at negative pi over 2. It would have been 0. So I shifted the sine graph to the left a half a pi over 2. All right, my domain is still going to be all reals. There's not room to write all that in there. The range is the same, negative 1 to 1. Remember, just like before, your zeros become asymptotes. So at pi over 2, 3 pi over 2, negative pi over 2, 5 pi over 2, I've got asymptotes. Okay. At 0, I'm at 1. Well, 1 over 1 is still 1. At pi, I'm at negative 1. Pi, negative 1. All right. Here I'm, let's see it. Am I, okay. The closer and closer I get to here, the smaller my fraction is, which means the bigger the reciprocal is. And my function flipped over like this. Okay. So my domain is going to be all values of x such that, you put that line in there, it means such that x is not equal to pi over 2 plus, how far is it from here to here? 1 pi over 2 to 3 pi over 2 is 2 pi over 2, which is pi. So every pi k. The thing is this one started on pi, and when this one starts at pi over 2, pay attention to that. Big deal, important. Okay, this goes from negative infinity to negative 1, and 1 to infinity. Likewise with the sine function, you can do negative values, okay, because it keeps going. Okay, now the tangent function. Let's see. Let's go purple. Okay, here's the, okay. We have 0, 1. Nope. Dang it, I did it. Did I do that every single time? Probably. It's 1, 0. 0, 1. Negative 1, 0. 0, negative 1. Okay. Now, remember the tangent is the sine over cosine. So 0 over 1 is undefined. So that's, is 0. So at 0, we're at 0. Then we have pi over 2, and we have pi, and we have 3 pi over 2, and we have 2 pi. Oh, we didn't talk period up here. What's the period? It takes 2 pi here, and it takes 2 pi here. Okay, back down here, sorry. All right, so 1 over 0 is undefined. If you divide by 0, it's an asymptote. This is 0 over negative 1. Well, 0 in the numerator means it's 0. This, it's 1 divided by 0. You got 0 in the denominator. It's an asymptote. And then you're back to here. Oh, that should have been just 2 pi. Beep, 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 typo. Okay. All right. The problem is we need to know what's going on in between. All right. So you can do this. Remember, this is 1/2 divided by, and this is root 3 over 2. So you do root 3 over 2 divided by 1/2, which is the same as root 3 over 2 times 2 over 1. These cross out, and you get root 3. I just like to memorize them. It's a 30-degree triangle. This is 1, 1, 2, and root 3. Okay. Oh, I did it wrong. I did this backwards. Oh, that should have been a 60-degree angle. Oh. So I was wrong. This is 30 degrees. These units go the other way. It's root 3 over 2 and 1/2. So you have, goodness, cut. You have 1/2 divided by root 3 over 2, which equals 1/2 times 2 over root 3. And these guys cross out and you get 1 over root 3, which is my 30, 60, 90 triangle. Okay, I like to draw the triangles. It's easier to get your tangents. All right, well, then I don't know what it is unless I get my calculator out. So what happens if I do pi over 4? It's root 2 over 2 divided by root 2 over 2, which is equal to 1. So at pi over 4, I'm at 1. And at this one of them's negative, so I'm at negative 1. And my graph ends up looking like an x cubed function. Okay? And there's an asymptote at the pi over 2's. Okay? So my domain is all values of x, this is right here, such that x cannot equal pi over 2 plus, how far is it to get from here to here? Pi k. The range is all reals. And the period, how often does it repeat? Is only pi. Okay? Rather than 2 pi. The cotangent, remember your zeros become asymptotes. So now we're going to have an asymptote at pi and at 2 pi and at 0. 1 over 1, so you're at, that was pi over 4, is 1. 0 over 0 is still 0. And what happens is my graph goes the other way. Okay, so the period in this case, oh, nope. The period in this case is pi also. The range is negative infinity to infinity. And the domain is all values of x such that x cannot equal pi k. All right? You need to be good at drawing graphs. Okay, so I said, oh wait, I need to draw the sine of x. F of x equals sine of x. I like to have both positives and negatives. I know it's at 0, at pi, 2 pi. It repeats itself. Then I do the backwards 2, negative pi, negative 2 pi. It keeps going down, up and down. You know, this is 1. This is negative 1. You have pi over 2, 3 pi over 2. Okay? Negative pi over 2, negative 3 pi over 2. Domain, all reals. Range, negative 1 to 1. Period, 2 pi. Okay? You got to get good at it. Draw them that fast. This is fun stuff. Alrighty? Alright, all I have for you on graph and asymptotes. Oh, no, that's not all I have. Alright, one more thing. It was too hard up there. Alright, if I need to draw the cosecant of x, okay, I know it's the reciprocal of the sine function. So a lot of times what I do is I go like this. And because I've got the sine function, it's pretty basic. Okay, we know that. I draw it in like this. And I draw it in dashed line. Now, to do the cosecant graph, whenever it's 0, I have an asymptote. Okay? When it's 1, that's the point, that's the point. This is, if that's a half, its reciprocal is 2. This is a half, this reciprocal is 2, so I know my loop is up here. And I know this one's down here. And this one's up here. This one's down here. Okay? And then I go back and erase my sine function, because I really don't need it. It's not part of my graph. Okay? And now I've done the cosecant graph. And you know your asymptotes are in the right spot because you started with the sine function. Just a thought. Happy practicing.